This is Algebra Lesson 1-7, the distributive property. Here are some important terms. Coincidentally enough, the first one's called a term. A term is a number, a variable, or the product of a number and one or more variables. So a term could be like 2 is a term, 3x is a term, 3x squared yz to the 5th is a term. Notice there are no plus or minus signs between them. That's what tells you something is a term. A term is something that is multiplied by something else. It is not added or subtracted. A constant is a term that has no variables. In other words, it's a number. Okay, 3, -7, 4/5, all of those are called constants. They're not going to change. A variable can change, but a constant cannot. A constant is just that. It is constant. It never changes. A coefficient is a numerical factor of a term. So in 3x squared yz to the 5th, the 3 is the coefficient. Okay, this 3 is called the coefficient. It's the numerical number of the term. It doesn't have anything to do with variable exponents. Okay, so the 2 and the 5, the 2 on the x and the 5 on the z are not coefficients. A coefficient is the numerical factor, which means it's the constant that is multiplied by all the variables. Like terms are terms with exactly the same variables raised to the same power. So example, 3x and 2x are like terms, so they can be combined. It's like saying 3 apples and 2 apples. 4x to the 3rd y squared and -7x to the 3rd y squared are also like terms because you have the same variables x and y raised to the same power, 3 and 2. So let's look at the following problem. 6 times 1/2 plus 1/3. There are 2 ways to solve this problem. Okay, the first one would be to with whatever in the parentheses first. If you follow the order of operations, which many people do, they'll look at this and say, ooh, I have to do what's in the parentheses first, which means I'm going to take 6 and I'm going to take 1/2 plus 1/3. Well, 1/2 plus 1/3, I need a common denominator, which would be 6. So if my common denominator is 6, 1/2 is actually 3/6 and 1/3 is 2/6. So I have 6 times 3/6 plus 2/6, which would be 6 times 3 plus 2 is 5/6, and 6 times 5/6, 6 over 1 times 5/6. The 6's would cancel out and we would just be left with 5. Now that's perfectly well and good and perfectly fine. However, I look at this and going, wow, it'd be so much easier for me if I looked at this and said, I need to take 6 times 1/2 plus 6 times 1/3, because 6 is being multiplied by everything inside of that parentheses. So I can take 6 over 1 times 1 over 2 and add that to 6 over 1 times 1 over 3. And I look at this and I go, okay, 2 goes into 6 3 times, and 3 times 1 is 3. 3 goes into 6 2 times, and 2 times 1 is 2, and 3 times 2 is 5. For me, that way is so much easier. All I did was use something called the distributive property. Okay? Because in this particular problem, you can add first and then multiply, or you can multiply and then add. That is the distributive property in a nutshell. Okay? The distributive property is the only property that combines both multiplication and addition and or subtraction. And it specifically states for every real number a, b, and c, a times the quantity b plus c is the same thing as saying ab plus ac. Or a times the quantity b minus c is the same thing as saying a times b minus a times c. And you can reverse those and put the a on the outside of the parentheses at the end instead of the beginning, and it just becomes b plus c times a becomes ba plus ca, and b minus c times a becomes ba minus ca. Examples with numbers. 5 times 20 plus 6 becomes 5 times 20 plus 5 times 6, which would be 130. Okay? Or 9 times 30 minus 2 becomes 9 times 30 minus 9 times 2. The distributive property is probably the most important property that you are going to use all of the time in algebra. So it is really important that you understand how it works. It's kind of like distributing something. If I came to class and I had cookies and I was going to distribute them evenly throughout the class, I would give each student in the class the same number of cookies. It would be unfair to me to look at people and go, ooh, you're wearing blue socks today, so you can have 2 cookies. Well, you're only wearing white socks today, so you can only have 1 cookie. That would be unfair. That would be unequal. I wouldn't be distributing the cookies correctly or evenly or fairly. So when we work with a distributive property, we have to remember that we have to distribute everything evenly. It's like distributing papers. If I was going to distribute papers, I would give each student a paper so that each student would have a paper. So when I use the distributive property, what I'm doing is I'm taking the number that's outside the parenthesis and I'm going to distribute it throughout the parenthesis. So basically I'm taking 3 and multiplying it by 4m, keeping my subtraction sign, and I'm multiplying 3 times 7. So that's the setup. And then to solve this, all we do is take the coefficients, or the constants in this case, the 3 and the 4, we multiply those together and we get 12, and we just tack on the little m, and we keep our subtraction sign, and 3 times 7 is 21. So we have 12m minus 21. 12m cannot be combined with 21 because there are no m's with the 21. Like terms have to have the same variable raised to the same power. The 12m has an m raised to the first power. The 21 has nothing. It'd be like taking M&Ms and adding them to bananas and somehow getting pineapples. You can't do that. So we just leave this as 12m minus 21. When we look at number 2, just because the negative is on the end, it doesn't make it any different. You're still going to distribute it the same way. I'm going to distribute negative 6 times 2x plus negative 6 times 1. So negative 6 times 2x is negative 12x, and negative 6 times 1 is plus negative 6. I prefer to write it as negative 12x minus 6. Again, they're not like terms. I can't combine x's with things that don't have x's. So I end up with negative 12x minus 6. If I look at problem number 3, just because I have a fraction, don't let it confuse you. It's the same process over and over again. We're just going to distribute this 12 throughout everything in the parentheses. So it's going to be 12 times 3 minus 12 over 1 times 1 over 6 t. So 12 times 3 is 36. 6 goes into 12 twice. So this becomes negative 2 times t, so it's negative 2t. Or you could write it as negative 2t plus 36. Either way is correct. I write it most of the time the way the bottom number is written. That's my preferred way to write it, because I tend to write numbers with variables first and numbers without variables second. It's just a preference thing. It has nothing to do with being correct or incorrect. As long as the negative sign is in front of the 2t, it doesn't matter if the 36 comes first or last. Number 4 says we have to do 4 times negative 3a plus 6. So that's going to be 4 times negative 3a plus 4 times 6. So 4 times negative 3 is negative 12, tack on my a, and 4 times 6 is 24 plus 24. And we are done, because we can't combine something with an a with something that does not have an a, because negative 12a and 24 are not like terms, so we leave it as negative 12a plus 24. All right, now recall that when we went back and did the properties of, the order of operations, that a fraction bar can be a grouping symbol. Right? It's another way of saying it's a grouping symbol. A fraction bar indicates division, and any fraction a over b can also be written as a times 1 over b. So you can use this fact and the distributive property to rewrite some fractions as sums or differences. So here it says, what is the sum or difference? What sum or difference is equivalent to each expression? Okay, so what we're going to do is we're going to separate these. This literally means that this is divided by this, and then this is divided by this. So the 4x is divided by the 3, and the 16 is divided by the 3. So you're going to put, basically, this is written as, you can write it as 1/3, because dividing by 3 is the same as multiplying by 1/3. okay? Because if I have 6 divided by 3, that is the same as saying 1/3 times 6. They both end up to be 2. So knowing that, each one of these divisors can be written as 1 over that. So dividing by 3 is the same as multiplying by 1/3. Dividing by 6 is the same as multiplying by 1/6. Dividing by 12 is the same as multiplying by 1/12. Dividing by 8 is the same as multiplying by 1/8. So I can take 1/3 and multiply it by, whoops, have to actually have my pen working right. 1/3 times 4x over 1 minus 16 over 1, or you could write it as 1/3 times 4x minus 16, whichever way you prefer. I actually like them over 1 because it's easier for me to show the multiplication properly. So if I have 1/3 times 4x over 1 minus 1/3 times 16 over 1. There, we distributed this. We went from this step here to this step here. So 1/3 times 4x over 1, multiply straight across the top and straight across the bottom, you get 4x over 3 minus, straight across the top here, straight across the bottom, 16 over 3. And you can't combine them because you have things without x's and things with x's, and you cannot combine the two of them. All right. So, and by the way, you can write 4x over 3 is the same thing as saying 4/3 x. 4/3 x is the same as saying 4x over 3. Those mean exactly the same thing. Okay, so if we have 11 plus 3x all over 6, so if I was going to do that, that means I'm going to have 1/6 times 11. I should do that right. 11 minus 3x, or plus 3x, excuse me. 11 plus 3x. So if I distribute this properly, I have 1/6 times 11 over 1 plus 1/6 times 3x over 1. So again, nothing cross cancels in the 1/6 and the 11 over 1, so it becomes 11/6 plus, but something does cross cancel here. 3 goes into itself once and it goes into 6 twice, so this becomes x over 2. Or some people will write this as 11/6 plus 1/2 x. They'll put the x off to the side rather than saying x over 2. Those mean the exact same thing. I have no preference on whether you write 1/2 x or x over 2. Makes no difference to me. Whichever one you are familiar with and you like best is the one you should choose to do. All right, letter C here. So we're going to do 1/12 times everything now. So 1/12 times 15 minus 6x means we're going to have 1/12 times 15 over 1 minus 1/12 times 6x over 1. I'm running out of space here a little bit. 12/15 does reduce. 3 goes into 12 4 times, and 3 goes into 15 5 times. So this would be a 4, and this would be a 5. So this becomes 5/4 minus 6 goes into itself once and a whole twice. So this would be x over 2. Or 5/4 minus 1/2 x. Doesn't matter to me which way you do it. All right, last but not least, we're going to have 1/8 times 4 minus 2x. So if I distribute 1/8 times 4 over 1 minus 1/8 times 2x over 1. 4 goes into 8 twice. This becomes 1/2. 2 goes into 8 4 times minus 1/4 x, or x over 4. So that's how you would write a sum or difference, which is equivalent to a number with a 1 fraction bar. Now you can write it as separate fractions. All righty. Okay, now we have to be really careful when we see a negative outside a parenthesis, because that negative has to distribute into the entire parenthesis. Otherwise, once again, we would be unfair in distributing things like my cookies, and I wouldn't be getting everybody a cookie that they would need. So this negative is the same thing as saying -1 times a plus 5. That's what that negative means. It literally means take everything in the parentheses and make it completely the opposite. So if I take a -1 and I multiply it by a, because this is going to be -1 times a plus -1 times 5. So it's going to become -a minus 5, or -1a minus 5. Notice how -a minus 5 is exactly the opposite of a plus 5. That's what happens when you distribute a negative throughout a parenthesis. If you're just distributing the negative, everything inside the parentheses switches to its opposite sign. So this becomes -1 times 4x minus 12, which is a -1 times 4x minus -1 times 12. Oops, there we go. Now watch these double negatives here, because they can be really, really confusing. So this becomes -4x minus a minus 12 becomes a plus 12. So you get -4x plus 12. Something I oftentimes like to do is, instead of having this as being 4x minus 12, I like to write it as 4x plus a -12. Because then when I distribute that negative to it, I get a -4x, and then minus a minus 12 becomes a positive 12. It really doesn't matter as long as you pay very close attention to your negative signs. Don't lose one of your negative signs in there. So here we're going to have -1 times -x plus 12. If I distribute, I get -1 times -x plus -1 times 12. So this becomes positive x minus 12. And x and 1x are exactly the same thing. I just don't tend to write the 1 in front of the x. All right, you can use your distributive property to multiply some numbers using mental math. For instance, 102 can be thought of as 100 plus 2, and 98 can be thought of as 100 minus 2. I do a lot of this when people ask me to multiply things in my head. I don't multiply 13 times 103 in my head. I multiply 13 times 100 plus 13 times 3. That's what my brain thinks. So 13 times 103 I think of as being 13 times 100 plus 3, which would be 13 times 100 plus 13 times 3. Well, 13 times 100 is 1300, and 13 times 3 is 39, so this is 1339. This is how I can do numbers in my head really fast, and people wonder and think I'm a genius, when really I'm not a genius. I'm just playing around with the numbers in my head a little bit, making them easier for me to combine because of all the different properties that we can use. Letter B here, 24 times 98. I think of 98 as being 100 minus 2, so I'm going to think of 24 times 100 minus 2, which is 24 times 100 minus 24 times 2. So 24 times 100 is 2400. 24 times 2 is 48. Okay, so 2400 minus 48 is going to end up to be 2352. Now you can do this with word problems as well. If I look at letter C here, it says deli sandwiches cost $3.95 each. I don't know where they're getting their sandwiches, but that's cheaper than where I get mine. What is the cost of 6 sandwiches? Use mental math. Well, I'm going to think of $3.95 as being $4 minus 5 cents. So I'm going to think of it as 6 times 4 minus 0.05, because 4 minus 0.05 equals $3.95. So 6 times 4 minus 6 times 0.05. So 6 times 4 is $24. And 6 times 5 cents is 30 cents. Okay, so $24 minus 30 cents is $23.70. Okay, so the cost would be $23.70. Remember, all word problems should always be written in a complete sentence to finish it. All right. All right. Now we're going to talk about simplifying algebraic expressions. And this is where it's really important because this is where you combine like terms, which means you combine variables that are raised to the same power. So an algebraic expression is in simplest form when it has no like terms or parentheses. For example, 2 parentheses 3x minus 5 plus 4x is not simplified. If I wanted to simplify that, I would distribute the 2 through out the parentheses, and then I would combine my like terms, and I would end up with 14x minus 10. So you can use the distributive property to help combine like terms. Think of the property as BA plus CA equals B plus C times A. Okay, so if we are looking for like terms, problem A here, combine like terms. So I have 5x squared plus 7x squared. This is x squared, and this is x squared, which means these are like terms, which I can think of this as being 5 plus 7 times x squared. Well, 5 and 7 is 12, so this would be 12x squared. Okay. I look at the next problem here. I've got 7x minus 5 minus 3x plus 2y plus 1. Okay, so let's look at our like terms. I know that 7x and negative 3x, a sign always goes with its number. The negative goes with the 3x. So I have 7 minus 3 times x plus 2y, and then I have a negative 5 here and a positive 1 here, which means I can then do plus parentheses negative 5 plus 1. So 7 minus 3 is 4 times x is 4x plus 2y, because there's no other y, so that can be combined with nothing. Negative 5 plus 1 is negative 4. So 4x plus 2y minus 4. If you don't like writing these parentheses, just think of it as in terms of this. What did I circle in purple? 7x minus 3x, that's 4x. Okay, what did I circle? What did I box in green? Negative 5 plus 1, that's negative 4. What's left over? The 2y. So I get 4x plus 2y minus 4. And order doesn't matter here as long as you have the proper sign in front of the proper term. All right. This last one here, I'm going to do like I did letter B. I'm going to look at this and say, okay, I've got 7y to the third z minus 6yz to the third plus y to the third z. Okay, so my like terms, 7y to the third z and positive y to the third z here. This is not a like term because it's yz to the third. It has nobody to pair up with, so you're not going to combine it. Y to the third z is the same as saying 1. This is the same as saying 1y to the third z. So 1 plus 7 is 8. So I have 8y to the third z minus 6y z to the third. I combine my like terms, the 7y to the third z and the 1y to the third z. That gave me 8y to the third z, and I don't have anybody to pair up with the negative 6y z to the third, so that just is left over. So those are your like terms, and that's as simplified as it can get because we cannot combine it with anything else. All right, your question for today. Answer the following question. What are 2 reasons to use the distributive property when simplifying an expression? What are the 2 reasons to use the distributive property when simplifying an expression? And please explain it fully.